the syntax in a brief while. So we have if, then we have a check condition. If that check condition evaluates to be true, then we will execute set statements of set of 1. So we'll execute statement 1. If in case this check condition evaluates to be false, then we will check for elif condition, check condition 2. Okay, we will check condition 2. In case this check condition 2 evaluates to be true, then we will execute statement 2. And if this condition evaluates to be false, then we will execute statement 3. So it works in the same way as it worked with if, else if and else. Okay, first it will check with if condition, then it will go to else if ladder, and there may be many of the else if elif statements. And after then at the end, if none of the elif statements evaluates to be true, then at the last the else statement will be executed, and then we will proceed with the further statements. Okay, so let me show you the syntax. The syntax of if, elif, else in Python is as such. We have if, then we will have the checking condition expression. So we will have that condition in expression 1. Then there will be a colon. Then we will have certain statements that will execute if this if condition evaluates to be true. Else will go to elif expression 2. Expression 2 will be evaluated to be true. Then we will proceed with the preceding statements. If that is also evaluated to be false, then we will move to the else statement. Okay, so else will be the last statement that will be executed. So let me show you one example how we can proceed with the decision making in Python, and then we can move to the next topic. Okay. Okay, so we can see over here we have this I have made this particular program for you where we are checking for negative or positive even and odd numbers. So I have collaborated two things. It has to be negative even number or positive even number, or it can be a positive odd number or a negative odd number. A simple question that we can give to our trainees. Okay, so we have a number, we are trying to input this number, we are prompting the user to enter a number. So it will say enter any number. And then see input, we had talked about the input function in the previous session. Input function by default always takes the input in the form of string. So whatever we are going to input through the input function, it will be default taken to be a string. So if we enter a number, if we input a number using input function, then we need to convert that number into an integer. We have to do explicit typecasting over here. So how we can do that? We can do that with the help of this int function, which actually typecasts the input number, which is by default a string, into the original integer. Then only we can perform certain calculations and check for even, odd and anything else. Okay, so we are prompting to enter number, then we are using input function to enter that number, and finally we are converting that input default string into integer and then assigning it to a variable, say num. Okay, now we are checking if num mod 2 equals to 0. If we are checking over here that num mod 2, this is the condition for even numbers, as we all know, and we are using here and. So here and or operators are used as string words. Okay, we don't use actually ampersand and all those operators over here. So this is quite easy, quite English level, English language is used very promptly over here. So we can say and num greater than 0. So for checking two conditions together to be true or false, we can use this and if only one statement has to be checked for true or false, either of them can be true, then we can use or. Similar to way we are writing and, we can use or also. Okay, so num mod 2 equals to 0 and num greater than 0, then it is printing positive even number. Then here we start with the elif ladder, because we can have multiple elif statements. There has to be only single if and single else, but multiple elif statements we can have. So elif num mod 2 equals to 0 and num less than 0, so it will evaluate to negative even number. Similarly, we have the condition for odd numbers, positive odd number and negative odd number. And at the last, when none of these evaluate to be true, then last is else statement, which says it's a 0. Okay, so we are working with this. So I entered a number, I evaluated it, and you can see the output. Suppose I entered any number, say minus 22, so it is giving me negative even number. So in the same way, you can work with different inputs and you can check whether it gives you positive even number or negative even number, positive odd number or a negative odd number, or it gives you a 0. Okay. Else ways we can also extend it, because we may enter some alphabets, we may enter some special characters, so we can evaluate, you can say we can change the message. For else we can say it's a special character, or it's not a relevant number, we can say like that. Okay. Anyways, so the next concept we are talking about is about loops. So let us go to loops. So let me take you to the concept first of all. Okay, so here we have loops. Loops are used for repetition. They are used for iterating over some specific lines. So it helps in code reusability if we want to write the same code again and again. All of us are very learned scholars, so I expect everybody knows about the loops and all this thing. So I just take you to the major part, which are the types of loops. In general, in all other programming languages, we have for loop, do while loop, and all such things. But in Python, we have only two types of loops. Here we have for loop and while loop. The do while loop that we had in Java and C, C++, they are not present here in Python. Okay, so just this is just to contrast between other languages and this language. Python language is made for simplicity. It is made to make your life easy, and it has so far very well served the purpose. It has served the purpose to make application development quite an easy task. Okay, now everybody or anybody can learn programming and write code, so that's the major part of Python. So it has reduced the loops to two loops. It has only for loop and while loop, and their working is also somewhat different from what we used to do in C, C++ and Java. Okay, here we also have break statement, pass statement, and continue statements that you can use with the loops. For loop, as we know, the purpose of using for loop is always to count the number of repetitions or iterations in advance. If we have that knowledge, okay, that so many iterations may happen, or we have the knowledge that it has to iterate over some iterable, like list, like set, like list of names, then if we have that iterable value with us and we know in advance how many iterations may be proceeded, then we can use for loop. It is always used in the case where we need to execute statements until the given condition is satisfied. And basically it is an entry control or a pre-tested loop. So you do not need to specifically check at the end that whether you have to move to the next iteration or not. It is an entry control loop. It will automatically work itself, keep on checking the iterable and keep on working with the iteration. Then we have while loop. While loop should be used when number of iterations is not known in advance. We do not have such concepts, such you can say specification in Java or C, C++. We used to have entry control and exit controlled type of concepts over there. But here specifically when we say number of iterations, if we do not know, if we have to use some basic condition, if we have some expression of condition and we want till that condition is true, we want to execute the loop, then we can use while loop. Okay, so while loop should be used when the number of iterations are not known in advance. In the while loop, block of code statements are executed until that condition is evaluated to be true or is satisfied. It is also an entry control or a pre-tested loop. Okay, so both the loops are entry control loop. So let me show you an example, then we can move on with other things. Okay, so let me show you one example for this. Okay, so you can use, first of all, let me show you, we can use a for loop to count the number of i's in a single sentence. Suppose we have a single sentence with us and we want to count the presence, the occurrence of that particular character in that single sentence until unless we encounter a full stop. Okay, till we encounter a full stop, till then we want to evaluate and count the number of i's, whether it is small I or capital I. So how we can do that? So if we have a variable, I'm declaring a variable, say count, and initializing it with the values is 0. So I'm saying for loop for val. So I'm using this val as the counter over here. So for val in, I'm using in operator to check the membership inside this string. So I want to check the membership of the value, means each and every iteration I want to check inside this string. Okay, so I'm using in operator for that. So hi dear trainees, it's a lovely morning to start learning. So we have this string with us. So inside this for loop, we need to go for indentation. Remember, the indentation is very important over here. So a tab space is important over here. So after tab, we put the if value. So if val in. So again, I am checking the membership, whether if this value counter will iterate over each and every character in this string, and it will check its membership in these two characters, whether the character is equivalent to small I or capital I. If it is, then it is going to increment the count by 1. It will say count equals to count plus 1. So this will increment it. Always one note over here, we do not have, increment and decrement operators like plus plus we used to have in C, C++ and Java. We do not have it over here. So we have count equals to count plus 1. We have to manually do it hard code. Okay. Then we have elif. Okay. After if, I'm checking elif val, if that value is equals to dot, okay, means the full stop. If it is equivalent to dot, then we can break out of it, means we can end the loop over here. Okay, so we can do it. You can modify the code as you want. This is my flow of working. You can modify it as per your choice. Okay, it is not necessary to put in else. You can end the loop. Okay, so here you can see if is there, elif is there, and no else is there, still this code works properly. So Python is a flexible language. It does not makes you forced to write all the syntax even if it is not required. Here in this case I needed to check only two conditions, so I used if and elif. I skipped out else and it is working properly. So it's your choice, you can work it anyways. So it will, after the end of the loop, after we break out of the loop, we can say print number of i's and ir. It will be equivalent to count. I specifically put a dot because the sentence, the question is to put a single sentence. It may be given a paragraph to you, so I wanted to end it at a sentence. So as per the string, it will work for only a single sentence. Fine. So it will count the number of i's and i's. It will take the small I also. It will check for all the small i's, and it will also check for a capital I. So in all the total i's or I, it will work out with 6 count. Okay. So this was a simple example for loop. The another example that we can work is with for loop with else. Okay. So for loop, in for loop, you do not specifically need to go for if and then use else. For loop has a direct integration with else. Okay, so if the for loop works, that's okay, and if in case the for loop does not work or the for loop is ending, then it will go to the else part. Else counterpart can be used. So for loop can be directly used with if elif, and for loop can be directly used with else. Okay, flexibility you can see. So numbers we have 0 1 5 7 9, and I'm using for loop just to iterate over this list of numbers, and it is going to print. So it will say print I. So 0 1 5 7 9 it will print, and once this loop is done with, once this loop ends, it can go to else and it can print list ends over here. So you can say 0 1 5 7 9, and after it has printed till 9, it is moving to else block and it is printing list ends here. So this is the flow of work of working with for and else. Okay, now lastly we can use while loop with infinity condition. Specifically I have done this for infinity condition to give you a concept that it is very typical to give a for loop with infinity condition. Although in other languages we had that that facility that we can use infinite conditions with for loop also, but here most of the time for loop is used over advanced knowledge of iteration. So infinity condition is 99% times not used or not integrated with for loop. It is a very specific and a very typical case of using infinity condition with for loop. If you want to go for infinity conditions, you should go for while loop. Okay, so that is why specifically I'm using while loop with the infinity condition. So we are counting vowels. Okay, the user has to enter a vowel. If he enters a vowel, then only he can skip and get out of the loop. Until unless he enters a vowel, he is stuck in that loop. Okay, so the loop will move on infinitely unless until the user specifically enters a vowel. Okay, you can modify the code as per your choice. This is my flow of working. Just see this. So we have vowels. We have this string of vowels. I have taken this complete string where I have in small letters A, E, I, O, U, and I have in capital letters A, E, I, O, U. So it is not necessary always to give a list or tuple. You can directly work with string also in this case, right? So we are creating an infinite loop. We are saying while true. This true is a Boolean value. This is a predefined keyword in Python. So this means the loop is entry controlled, and entry controlled condition is true. The loop is going to definitely work. Okay, so in case we want the loop to work in all the cases, in all the scenarios, we want to have this infinity condition of true. Okay. So val equals to input. Again, I'm prompting the user to enter a vowel to exit the loop. So whatever value the user will enter will be input to val. Here in this case, I'm not typecasting it because I want to check for alphabet string only. Okay. So that is why no typecasting is required. So if val in vowels, now I'm checking for string. So I can check the membership using an operator in the string also. So I'm checking if val in vowels. Okay. Then break. Then you can break out of the loop. If else we can say print value entered is not a vowel, please enter again. So user is stuck in this loop. He has to keep on entering the vowel unless until he reaches this break statement by entering a vowel. Okay. After this loop ends, we can say successfully entered a vowel. So you can see I have implemented this way with various inputs. I said enter a vowel to exit the loop. We entered 7, then it says value is not a vowel, please enter again. Then I entered pp, again it said. Then I entered special characters, again it said. So once I added I, then it was a vowel. So it exited out of the loop and it printed successfully entered a vowel. So this is how, guys, we can work with for loop and while loop. So this was the remaining part of what we actually wanted to cover with the session 1. So loops are done and we have also done the decision making part. I hope so far everybody has that complete knowledge. No doubts would be there. Okay, so I directly take you now to the to another thing. I'll take you to other libraries, okay, because we need to start with the data pre-processing part also. So I'm just stopping the presentation for a while and then I open the next screen. Okay. Okay guys, I hope my screen is visible once again to all of you. Okay. Sonia ma'am, can you give a check? Screen is visible, session 4.
Yes, ma'am.
Yes, ma'am. Yes, okay. Thank you. Thank you so much. Thank you. Okay, so this is session 4. We are starting with session 4 right now. Okay. Now, this session deals with data and its pre-processing part. Okay. So before we actually proceed in on to data pre-processing, we need to know about the data. In analytics, we have, uh, you know, we have this particular thing of division of data, because when we talk about data analytics, we have a lot of resources of data. We have some videos, we have images also, we have some feedback also. Recommendation system works on your feedbacks, on your complaints. So we have a lot of text over here. So we have different forms of data. So that is why we have categories of data. We need to know the categories. So we have two basic categories of data. One is qualitative or categorical data, as the name suggests, because it is all about categories. This data can be divided into categories. Then we have quantitative data, which can be a discrete data, that means unique or distinct data, or it can be a continuous data, which means some kind of range of values like temperature ranges or rainfall ranges, or it can be some ratio also. Okay, so let us talk about this data in quite detail. So when we talk about qualitative or categorical data, that cannot be measured or counted in form of numbers. You cannot specify them in the form of numbers. Rather, you have categories like good data, bad data. You have poor feedback, good feedback. So you have you have basically that categories through which you can categorize your data set. Okay, this data may consist of some audio files, it may consist of images, symbols, text, it can be anything. And basically in business, when we talk about business use cases, then in business, qualitative data tells about the perception of people, because in business, BI tools right now, they are using the real-time data that they fetch from user preferences. Okay, they want to understand what customer wants, what is the feedback of the customer, what complaints or what grievances he is facing, and then according to that they are deciding their product strategies. So data analytics has a very crucial role to play in business intelligence. And over there we have this qualitative or categorical data a major role to play. Okay, we can see some examples of qualitative data, like we have languages of speech. Suppose there we can categorize data in the form of like Hindi language data, we have English language data, or Chinese or German language data. So languages of speech can be a form of categorization. Then you have popular holiday destinations. So there may be categories where we have popular holiday destinations, or low budget holiday destinations, or high budget holiday destinations. Most of the websites nowadays, they use qualitative data based on the user preferences, how many bookings are done for that particular destination. So that particular preference or feedback counts a lot. So we have people's opinion, agree, disagree, neutral. Again, we have three categories. We have agreeing, people are agreeing on something, people are disagreeing on something, or people are neutral towards things. Okay, then we have hair color, eye color, blue eyes, green eyes, black eyes. So all these examples that I'm giving you about qualitative data, they are containing certain categories. You can bifurcate or you can assemble the data according to the categorization. So that type of data is specifically used for classification applications if we talk about machine learning applications. Okay, then inside qualitative or categorical data, we have a nominal. We have a specific subcategory which is nominal, which its name comes from nomen. Nomen means name. Okay, it's a Latin name which means name. So it is basically used to label variables without any order. You do not have any order. You do not have any quantitative value. Just simple categorization is there, and that categorization can be in any order. You cannot sort data. You do not have to do any numerical tasks with this data. This data is all about string categories. There is no numeric forms. There is no you can say sorting, or you can say some calculation part. Nothing is over there. You have to encode this data. These categories need to be encoded for further working on them. Fine. So anyhow, you can see some examples of nominal data like color of hair that we talked about. Qualitative data, qualitative data's category is nominal data. Okay, so it's like color of hair, which can be blonde, red, brown, black. Marital status, that can be single, widowed, married. Nationality, Indian, German, American. So you can say there is no order, whether you write German first, Indian second, or you write American second, Indian first. It has no order attached to it, no indexing attached to it. Gender can be male, female, others, eye color, black, brown. So there is no sorting, no calculation that can be done with this kind of data, unless until this kind of data is encoded, and that is what we will talk about in data preprocessing part. Okay. Okay, anyways, the second category of qualitative data is ordinal data. Ordinal data is something where you have natural ordering. Okay, you are not giving any indexing, you are not giving some specific order, but by default it has an order. Let me give you an example, then you will understand this particular fact. These data, like for example, you would have seen after you do a shopping, or you talk to some customer care executive, he tells you that please give me a rating of 5, or just you will have that feedback form in your email box. Just give me some rating, some feedback. So you give that feedback in form of stars. You just select 1, 2, 3, or 4, 5 stars, or whatever you do. That is the natural ordering. Okay, that numbering itself is a natural ordering. Ranking is itself a natural ordering. Suppose say customer feedback or rate on a scale of 1 to 10, it is itself an order. You are not giving an order, the numbers themselves suggest an order. Okay, now ordinal data is a qualitative data for which values have some kind of relative position, which is not given by user, but it's by nature it has. For example, you can say result grades. We have A, B, C. Now we by default we know A grade stands for somebody who has outstanding performance. B grade is somebody which has average performance, and C grade is for somebody which has poor performance or lower than average. So we have that kind of thing. Or ranking, we have first rank, second rank, third rank. This is through the nomenclature we have. This is again the nomenclature we have, which has itself inbuilt ordering. Okay, financial status, high, medium, low. Again, you are not giving anything. High status, it means it's high value. Medium status means it has average value. School education level, again it is high, secondary, or primary it can be. Fine, this way it works. Okay, Next, we come to the second broad category, that is quantitative data. So quantitative data can be expressed in numerical values, which makes it countable and includes statistical data analysis. So it includes calculations, whatever calculations, statistics, analytical part you want to do with data stands here in quantitative data. As its name suggests, it is not about quality, it is not about names, it is not about categories. It is about quantity. It is about the value, the amount. Okay, so you have, you have the questions. When you have the questions raised by data such as how much, how many, how often, where you can quantify things. How many, we can say 10 times. How much, we can say a huge amount. Okay, or 10% amount, 20% amount. We have the answers like this. Or how often, we can say multiple times. We can say 3 times in a week. We have that quantity with us, we have that answer. So that kind of data when we have is known as quantitative data. So quantitative data can be used for statistical manipulation, and these data can be represented by a wide variety of graphs. One of the most important graphs then you can use for such kind of quantitative data is bar graph. You can use histogram also, scatter plot, box plot. Basically visualization can be done easily when you work on quantitative data, because after calculation, after finding out mean, median, everything, you can build a scatter plot. You can just build a histogram out of it to see the distribution. You can create a pie chart just to see how much quantity of data stands where. So all these kinds of graphs, they work on quantitative data a lot. So quantitative data example, you can see when we have height or weight of a person or object, we have room temperature available with us, scores or marks available. So when we talk about grades A, B, C, that stands for qualitative data. When we talk about specific marks, we have quantity 50 marks, 80 marks, 70 marks, then it is quantitative data. Similar to that, we have time. Okay, so time also stands in quantitative data. Okay, so quantitative data has a subcategory which is known as discrete data. When we talk about discrete data, it means distinct values, different values, that has to be, unique. Fine. So discrete data contain the values that fall under integers or whole numbers, definitely. And most of the times when we talk about visualization and we work with some that kind of decimal values, we try to round up it. Okay, this is a general phenomena that we do when we do pre-processing also. We generally try to take whole numbers because our ultimate aim is to plot that analysis in a graph. So graphs, they, most of the tools, whether you talk about Tableau or Power BI, they do not work on decimal numbers. They take the data in whole numbers, in, round up numbers. So that is why our general pre-processing technique says, if you have decimal numbers, have the strategy either round down if you have that specification, or round up, okay, if you have that specification. Anyways, so you work with that data which cannot be further broken into decimal or fraction values. The discrete data are countable and have finite values. Their subdivision is not possible. So you can see some examples, like discrete data examples may be total number of students present in the class. It has to be unique, it has to be a specific number. Okay, cost of a cell phone, it has to be a number, it cannot be broken down. Number of employees in a company, again it has to be a number value. Total number of players in a game or days in a week, so it has to be a round up number. Fine. Okay, coming to continuous data. Continuous data is obviously in form of fractions. When I say fractions, I mean a range. Okay, for example, I may say that this year rainfall may be from 10 mm to say 50 mm. I can just give a range. Okay, or I can say the temperature may range from 25 degrees Celsius to 40 degrees Celsius. So I am giving a range, a minimum and maximum, and within that range, different values can be taken up. So it is not a distinct value, it is not a specific value, it is a continuous data which is a combination of a lot of values, which has a range or a ratio of values. Okay, for example, like height of a person, now it cannot be very specific, it is always, in the range. Okay, 6 feet to you can say 5 feet to 6 feet, within that range. Okay, speed of a vehicle, again it is in some range. Time taken to finish the work, again you give a range. I may finish it in the range of 30 days. Okay, within 30 days. Frequency, bandwidth, all those things. Market share price, again it keeps on moving and jumping here and there because it again moves in a specific range. So wherever you are working in a range of data, in a ratio of data, you are working with continuous data. Okay, Now, before I again go to the machine learning part, I have to start for data pre-processing on machine learning. We have talked about data. So just a summary of what we have done up till now from morning, who all have joined, let me just brief you. We have talked about the basics of Python, the need of Python, the features of Python. We have talked about the installation part of Python, Anaconda Navigator, Jupyter Notebook, how to create a new Jupyter Notebook. Then we have talked about the data types in Python. We have talked about different types: list, tuple, set, dictionary, strings. We have done all of them. We have talked about the loops part in Python. We have talked about decision making in Python. Then we started with the types of data. Okay, now the types of data is not specific to Python. I told you the types of data, this categories, all these are relevant to data analytics part. Okay, when you are in broad terms, you are working with analytics and you want to categorize the data, because data is gold and diamond for you in analytics field. It is the most important thing. Everybody is after data. So I take you from data now to data pre-processing and machine learning part. Okay, so before I carry on with the domain of AI, ML and deep learning, let me just give you a brief out of how they are different. I hope this may not be a redundant topic, but it's good for me if I just take you from the very scratch to what is the need of extracting data, what is the need of pre-processing data. So these are the buzzwords of nowadays. The buzzwords are AI, machine learning and deep learning. Okay, when you talk about AI, you talk about smart machines, you talk about intelligent machines, the robots. Okay, but guys, just understand this thing: robots is only not the only feature of AI. Okay, you have automated scripts also, which is a part of AI. Nowadays you have Echo Dot, you have Alexa, Amazon Alexa, you have all such kind of gadgets. Okay, in fact, Google Assistant that you work on with your phone is a smart AI itself. Or when you are chatting, you don't know whether a person is sitting or a bot is sitting, because automated scripts are working. So all of them, that robotic processes, they all are a part of AI. Okay, so this is important to know, that AI is a big domain. It contains smart machines, intelligent machines, where machine has the ability of artificial thinking. If you just check out nowadays, there are a lot of working is going on robots. Okay, and in the COVID era especially, if you had read about this, AIMS hospital had specifically employed robots to serve the COVID infected patients, because their doctors and nurses were already getting infected. So they worked on different robots. The robots used to take care and manage the patient. So this happened in AIMS Delhi. Okay, anyways, let's go to machine learning part. Now, how machine learning is slightly different from AI, because AI consists of machine learning, but machine learning is itself a subset of artificial intelligence, where you are giving algorithms, you are writing code for training your machine. You are training your machine once a while to do a specific task, and finally that machine is itself working again and again on that same repetitive task. There is no, you have to train a machine for a specific thing only. Like, suppose I am training my machine for predicting price of housing, okay, of Delhi area houses. Okay, now my machine gets trained for Delhi regions housing or property rates, and it starts predicting according to the new data given. But the algorithm is running for that particular thing only. Now smart devices, what which, as compared to Delhi, it starts comparing itself with respect to Mumbai, it starts comparing itself with respect to other locations also. So AI is a broad term which includes deep learning as well. Machine learning is you are training algo for a specific task. Okay, now when we come to deep learning again is a subset of both AI and ML, and here we are specifically talking about neural networks. Okay, earlier machine learning was a broader domain which included neural networks, but nowadays a hell lot of research is being done into deep learning, where you are digging out or making very very complicated neural network machines. Okay, so that is why this deep learning is nowadays a specific research topic which is being taken up by many. So this is a subset of both AI and ML, and it deals with massive amounts of data, and its name is deep learning because you have a lot of depth of the neural network. The name deep comes from the part that neural network can be of any level of depth. It means any any I can say level of neurons you can have. Okay, that iterations, the iterative level of neurons makes it deep. The more number of iterations for neurons you have, the more deeper your network is going to be. Okay, anyways, so I'm not going into details of AI, just want to show you the applications. There are many applications of AI, whether it is image detection, speech recognition, or decision making. You can use AI in the video games also. You have seen a lot of video games that are using AI or virtual machines. Okay, you have simulators, you have smart devices, chatbots, your Google Assistant, virtual assistants, your Amazon Alexa, your Echo Dot, smart devices. All those devices are nothing but applications of AI. So you have functional types of AI, which are interactive AIs, which are chatbots or personal assistants. We have text-based AIs, which are text recognitions or speech-to-text convertive systems, like you have used on Google, where you are actually converting one language into another. That is text based AI part. Okay, apart from that, you have text recognition, where it is recognizing which language you are using. Okay, and that is a specific AI. Or nowadays, when you are seeing videos, if you have checked out some videos on Udemy, then what they do, whatever the speaker is speaking on the video, that is converted into text, and you can copy that text and use that text. So that is speech to text conversion that is happening in video streaming. So that is also a part of text based AI, and it happens on real time. Okay, there's similar to that, we have functional AI. Functional AI means something which is real time happening in gadgets, where you are trying to connect your robots, where you're trying to connect your gadgets with AI solutions. Like nowadays, what I have done at my home, we have integrated IoT based bulbs. Okay, IoT based bulbs and tube lights, which are smart bulbs and smart tubes. It is connected with our mobile phones, and through that we can work simply on these gadgets. We can simply give commands to Alexa also, we can simply give commands to our geyser also. So all these IoT based smart solutions are also a part of functional AI, where we are integrating AI programming with IoT. Similar to that, we have visual AI, where we are using augmented reality, which are VR devices that we have, virtual reality devices. Or we are having human augmentation, where you can see some sci-fi movies, they are showing this thing that totally the person is immersed in that screen, and it is able to interact with everything. So that motion, that sensing is provided by visual AI. A very very important domain that is being worked upon is visual AI nowadays. All your hi-fi, that visual effects, everything is given through visual AI. Now analytical AI is all about sentiment analysis, supply risk assessment. Now this is a total business use case. When you talk about analytic AI, it is being worked upon by businesses, because businesses nowadays, they want to they don't want to stay behind. They all want to have that knowledge about the user, what my user wants, what is the perception of my user, how can I stay ahead from my competitors. So that that particular thing is they get from their data, and their data is used to extract the sentiments of the user. Okay, from which to which product this user sentiment is good, which is bad, which is not selling, and all such analytics. So all that parts, when it is done through automated scripts, it is done with the help of analytic AI. And risk assessment also, when we are making new projects or new pipelines are being set up, or some kind of risk based projects, so they do analytic AI just to see what are the future risk or probabilities of having risks for that project. Now I here with project, I mean real estate projects, or those projects which are actually having a very crucial factor related to human life. So those projects, they specifically work with analytic AI just for risk assessment part. Okay, anyways, when we talk about ML, so you can see ML machine learning model, you have three things in hand. You have task, performance and experience. So if you see, the formal definition of machine learning was given by Professor Tom Michel of School of Computer Science, Carnegie Mellon University. So what does he say? According to him, I'm quoting this particular definition given by him for machine learning, because he is termed as a working father of machine learning. Okay, so a computer program is set to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. So I would just simplify this particular definition, because it is integrating three things. We have a task at hand, we are performing some task, we have to check the performance of that task, whether that task is going in a good direction or in a reverse direction, reverse gear is there. Now this happens in terms of experience, because in terms of experience, no, your performance may improve. The machine learning model I explain to my trainees with respect to their own past. Like when they were children, they were small, they didn't know many things. This gradually with experience they learned so many things. They learned new subjects, they learned their domain, they learned how to program slowly. Now their performance is good. With experience, the performance evaluates to be improving. So the Tom Michel says so about machine learning, that it's a computer program basically which is performing some task T, and we are measuring continuously its performance P. With experience, that performance P of that task T is improving slowly, steadily. It is improving. Okay, so this was simplified version of this complete definition. So ML basically consists of these things. We have to improve the performance, we have to keep on executing that particular task till its performance is good, and over the time with experience we need to modify some parameters just to improve the performance. We'll see. I think in the coming lectures, coming sessions, day or day after tomorrow, you are going to see a lot of machine learning algorithms. So you are going to see how to improve the accuracy part of each and every algo. Fine. So let us talk about this machine learning process. So I just take you to the working model of machine learning. This is how a working model works. If you see this flow diagram, you have some training data. Training data is what? It is a sample data. It is some training material. Okay, just like like a naive person, you are giving some data. The machine is also naive. It does not have any experience. So you are trying to train that machine. So initially you give a training data. This model is basically especially for supervised learning, because when we talk about unsupervised and reinforcement learnings, then the flow is somewhat different. You are not exactly having those training data and classification. So I am first of all taking you to a simplified version with respect to a supervised learning model. Okay, so we have some training data. We are training the machine learning. We are training the machine using an ML algorithm. We have specified that ML algorithm, whether it is regression that has to be used, or it has to be classification that has to be used, or decision tree, or it has to be some random forest, or support vector machine, or whatever algo has to be used. So we have decided that particular algo, and we are trying to train our machine using that algo. We have modeled the input data. Okay, after setting all the parameters, after pre-processing the data, we have started modeling the data. We have started seeing the accuracy part, how much accuracy the machine is showing with that ML algorithm. Once you feel your machine is trained, after some iterations, okay, you feel your machine is trained, you give a new input data to your machine. Now that if that algorithm with that new data, if it gives accurate results, if it starts predicting the correct category, if it starts predicting the correct output, because this new input data, for this new input data also you have the output with you. Okay, this is the test data basically. When you divide a data set for machine learning, you have two types of data. One is training data. Half of the data is 60%, 50% or 60%, probably we keep it in the range of 40 to 60. What I have seen is 40 to 60% data you keep for training. Okay, and after that the remaining data you keep for test. So this new input data is basically your test data, which you give to your machine learning algorithm, that does some prediction for you. Okay, the output that you wanted to see, it does some prediction for you, and if that prediction evaluates to be accurate, then you say that your model is successful. And if in other case, if that prediction evaluates to be inaccurate, or there is some wrong outputs that it is giving, then you need to do again. You need to either change your algo, or you need to do something else. Like for example, if you are working with decision tree algorithm and you feel like accuracy is not being very good, there is problem of bagging or boosting over there, then you need to go for another algorithm. You may try going for random forest. Okay, this is just a simple example. You may decide to switch your algorithm in case your algorithm is not giving you higher accuracy or high good outputs. Okay, so this was a working model of machine learning working, right? Basically. Okay, so these are the big market players. You can see all the big names, whether it is Google, Netflix, Amazon. Google is a lot there because Google nowadays has its own complete data analytics platform. If you have heard about Google Colab, you can on real time you can work on the code over there. I am not showing you Google Colab because Google Colab is only meant for simple execution, simple working. When you need to go for higher level or complex programming, then you need to actually work on Jupyter Notebook and Spider. These two are your lifesavers. So that is why I planned this training for Jupyter Notebook. Okay, but otherwise, whatever codes you are doing, you can do them same in Google Colab also. It's a real-time free application that you can just log in with your Gmail account. Fine. So you have Fitbit. You can see Fitbit. Everybody is using machine learning and AI system. Okay. Anyways, now we have a brief knowledge of this thing, that machine learning applications, they need data to train. Okay, to train your system, I need this data, this algorithm. Algorithm needs the input is your data. The good data you have, the more better data you have, the more better outputs you're going to get from your algorithm. So your machine is also simply like your golden in golden out fundamental works over there. If you have good input, the output is going to be a better one. If you have garbage inputs, you have not preprocessed your data in a better way, and you have imported very rudimentary data, very raw data, then the output is not going to be very good, and the predictions are also going to be compromised in that case. So here, since we know the need now, so we can work on with the task. We now know what are data pre-processing tasks. It means we need to pre-process or clean our data before we are actually going to input that data into our system. Okay, so it's a very huge topic, very big thing, it's a very time consuming topic. I will try to give you a good glimpse of how data preprocessing works, because there are hell lot of algorithms over there. There are hell lot of algorithms for encoding, for sampling, for scaling. There are so many concepts. So I will just try to give you a glance of those things. At least you get the direction, and then you can work on these things more. Fine. So let us talk about data preprocessing. Now, basic learning principle. Now, what is a learning principle? When I talk about machine learning, machine, I understand machine is my machine. Machine is this computer system, or the system which you want to train. But what is learning? Learning principle is something which says the features, also called independent variables, are the variables containing some information using which we can predict the information contained in so-called dependent variable. Okay, I just give you a simple example to understand this. Okay, suppose I need to go to my office regularly I need to reach my office at 9 a.m. For example. Okay, I need to reach my seat by 9 a.m. Now, when I set from home, when I set in the morning from home, if I'm setting off at say 7:30 a.m., then I have parameters set in my mind. Okay, I have a lot of time. The vehicle is available or not, whether I should use a metro or not, whether I should book a cab or not. So all these are some independent parameters that I'm thinking about, so as to reach the ultimate aim, to predict this thing, that whether I should reach, whether I will be able to reach by 9 a.m. or not. So all these are independent variables that help you to decide whether you will be able to reach there, whether what will be the prediction for the dependent variable, because reaching there has the dependency on what transportation you take, at what time you set out, what are the other features, whether it is raining or not, whether the whole area is flooded or not, or whatever is happening. All those are different independent variables that help you, or that help the machine to decide for the result about independent variable. So these independent variables help you to predict the information contained in so-called dependent variable. And dependent variable is generally the output that you want to predict, whether it is going to be categories, whether it is going to be classes or something like that. Okay, so if you have that classes, you have three categories and you want to divide your data into that three categories, you want to assign a particular category to each data, then the category column is going to be your dependent variable and all other columns are going to be your independent variables that will help you to decide the classification, that will help you to decide the category. Okay. Okay, this was the basic learning principle, that there are some independent variables that help you to decide about dependent variable. Okay. Okay, now what is data pre-processing in this regard? So in any machine learning process, data pre-processing is that step in which the data gets transformed, encoded, so as to bring it to such a state that now the machine can easily parse it. Every time, okay, this is every time. Simple machine learning, you always do that in your simple programming also. If you take, you need to transform your data. You cannot simply put whatever data you have in your machine. You have to transform it into a basic, you can say, a frame, or you can say this, the term is data frame obviously, but I would suggest you that you can think of it in a format, okay, in a particular format that is easy for the system to understand. The system can understand in this way whatever transformation you are doing, in that way the system can only understand. Then you need to encode some data also. Okay, you need to encode the data, like you had qualitative data or categorical data that I started off in the beginning. That qualitative data you need to encode that. Okay, so that encoding, you have a lot of encodings available to you, like the most important or popular one is one hot encoding that we'll see today also. So that encoding algorithms, binary encoding you can use, that is done to encode qualitative data, that kind of categorical data, into a numeric form, a quantitative one that you can actually analyze or do some calculation. Okay, so you cannot directly work with strings now. You cannot do any calculation with hair color or eye color, or you can say citizenship or nationality, whether it is Indian, German, American. You cannot do anything with that particular string. You need to encode that string, then you can perform some calculation and give some analytical output. Okay, so you need to encode it to bring to a state where it can be easily understood by the system. So features of the data can now be interpreted by the algorithm. The data set can be viewed as a collection of data objects, where you can say it can have records, points, vectors, patterns, events, anything it can have. Okay, so data preprocessing task. If we talk about data preprocessing tasks, then there are going to be 7 basic tasks of data preprocessing, which consist of identifying features. First of all, what are the relevant features? Now this is something very very important. This entire field, all of you are so learned people, you may be knowing about the concept of feature engineering, feature extraction, and all those all concepts, they actually stand here, these at the beginning of machine learning, because you have so many features available to you. For example, if I simplify the example, suppose I need to decide whether what is the best criteria for defining an Indian citizen, because Indian citizen nowadays has so many numbers. If I talk about me, I have Aadhaar card number, I have voter ID number, I have ration card number, I have license number, I have PAN card number, and God knows driving license number. We have passport also. So there are so many columns. If I just create a data set of Indian citizen, then it is going to have a lot of columns in that. So out of that, what is the most important column that will help me to engineer my feature, that will be extracted as the most important column that can help me identify an Indian citizen? It cannot be one, it can be one or two or three, or okay, or not, obviously not hundreds of them. Fine. So that is the basic part of identifying important features. You need to engineer your features, right? So after that, you have data quality assessment also, where you are actually assessing your quality of data. You are seeing whether this data has a lot of nulls, whether you need to replace some data, you need to, because the data is considered to be good quality if it has very very less amount of nulls. Okay, if it is having a very very huge amount of null values, or it is having very error prone values or rough values, raw values, then it is not a good quality data. So once you identify the data, once you identify your important features that you're going to work with, then you need to check the quality. Quality check is very, very important for data. As I told you, it works on the principle of GIGO. You give golden in, you get golden out. If you give garbage in, definitely you are going to get hell lot of garbage out. Okay. Anyways, the next thing is feature sampling. Okay. Now again, feature sampling, after you identified those features, now again you need to decide upon the sample of the feature, with what is going to be your independent variables, what is going to be the set of dependent variables, and how you are going to manage with your new data set. This especially is a tough task when you are working with a new data set. Okay, the data set for which we have a lot of experience, we can work with it, but for a new data set, sampling is a very, very important task. Okay, then you have feature aggregation. There may be some features which may be having repeated values. For example, your date of birth and age, they are both those values which have repeated data. Okay, so similar to that, you can aggregate that column into a single column. You can keep one of them, so you can aggregate columns and aggregate multiple columns also to get a single information out of that. Similar to that, we have data encoding, which is especially done for qualitative data, where you need to encode that data. You are giving some coding to that data, binary coding. Basically, this is essentially a binary coding. It will convert, it will elongate your columns. Okay, if how number of categories you have that you are encoding, according to that categories, the number of columns will also increase. So data encoding is actually the point where your data set elongates. So you need to keep a scope of having huge data. Okay. Next is feature scaling. See guys, when you are working with machine learning model, okay, you have to consider this thing that it may happen that low value of data may also have some relevant information, whereas high amount of data, it always may not have a high importance. For example, if I say I have two columns, one is age and one is salary. Okay. Now age column is having small number of values, because maximum age of a normal human being can be 100 years, and a working age has to be below 60 years. Okay. So it is going to have values like 30, 35, 40, something like that. And salaries, by the way, are going to be huge. Okay, it may be happening that a 30 years of age person may be earning 1 lakh rupees, whereas 40 years of age person may be earning only 80,000 rupees. Or it may be happening that 50 years of age person may be earning only 30,000 rupees, depending on whatever they are doing. Okay, so age is having smaller number, but it is having high importance. Okay, because 30 years of age you can consider to be young person earning higher amount as compared to an older person earning lesser amount. So the importance cannot be given on the basis of that value, 30, 40, 50 compared to 1 lakh 40,000, 50,000. It seems very low, and machine is a dumb machine. Okay, our computer system is a dumb machine. It is going to think that this salary amount, the numbers are so huge, so they are only important. So these important features are going to hide those columns which are having less values. Okay, which are having low number values. Okay, low value. So just to avoid this particular thing, just to to avoid falling into this trap, we need to scale our features. So feature scaling is done to bring all these columns on a single platforms. It means we can range it, we can scale the columns in a particular range, where that range is going to be same, that ratio is being taken up, and that scale will actually scale out age also, and it will scale out salary also. And now all the values, when they fall in a range of numbers, then no one is more important than the other. I hope I am trying to make the things clear, and it is getting clear to all of you. By the way, we are going to talk about them more, so no problem. Finally, after we are done with features, we have done the complete task of feature engineering. Okay, this is our feature engineering tasks. So we are done with that. We have to split our data, because now we need to give this data to our machine learning algorithm. Data splitting divides the data into two categories. One is your training data, as I told you. Second one is your test data. Training data, as the name suggests, it is training. For example, all of you are academicians. You give the notes to your students, you give training to your students, and you tell them important questions. Okay, this may happen, or we may ask you this question, or this is an important question. This is all training data that you are giving them. What is given them in their end term examinations, when they are finally sitting for examination and they have their end term paper, that is their test data. Okay, so whatever happens in real life goes same way in machine learning. Whatever we are giving the data in at the time of training, we are setting parameters, we are giving data at the time of training, that is training data. Okay, we are training our machine according to that data. And finally, when new data is given and its performance is checked upon that, that data is known as test data. Okay, so this was data splitting. So I quickly take you to the details of all of them. When we talk about features, features are the columns in a data set. You can say all the features, the characteristics of the object, like physical object at the time of which an event occurred, or anything. Okay, whatever attributes or dimensions you have in your data set are termed as features. So they are often known as variables, characteristics, fields, attribute, dimensions. All these things are termed as features. A feature is an individual measurable property or a characteristic of a phenomenon being observed. So if you talk about features, first of all, we did the types of data. Now, as comparison to data, because data is there only in the features. So with regard to that data, we have feature types. We have feature types in the categories of numerical or categorical. So categorical, again you can say it is qualitative data, numerical again you can say it is quantitative data, and categorical again leads to two categories of nominal features and ordinal features. Numerical or quantitative data again lands into two categories of interval features or ratio features. So you can see the types of data that we studied has now got into the way of types of features. Okay. Now, first point was data quality assessment. So this is the categorization of features. We have gone down to features columns. Now, data quality assessment, we are trying to assess the data for a quality, because data may be taken from multiple resources and it may not be in a particular format. Because when you work with data, some data may be, you may be getting from website, some data you may be getting from your cloud services, some maybe you may be getting from surveys, some maybe your internal data or your competitive data. So these are in different formats. So you need to, convert them in a single format. Suppose the single format may be Oracle based format. So you need to convert entire data into Oracle format. Or it may be working on MongoDB. So you need to, convert every data into NoSQL format. Okay. So it means either you can convert it into RDBMS format or NoSQL format. Okay, so it depends on entirely your requirement, where you need to convert the entire data in a single format. Okay, it is not practically possible to assume the data obtained will be perfect. So there may be many errors, there may be flaws, there may be null values. So you need to assess your quality. So techniques for ensuring data quality. So first technique is handling missing values, because you may be having empty values. People may intentionally or maybe unintentionally they filled up with no values, missing values. So in order, if you have missing values in the data set, so we need proper handling. So it can be done by two methods. We can eliminate rows with missing data. Okay, straight away you can eliminate rows with missing data, or you can estimate missing values and fill them with mean, median, or mode. See guys, both the techniques they work at real-time projects. When you but there is one important thing. When you go with solution number one, when you say eliminate rows with missing data, now a very important problem that is associated with this particular solution is that when I am eliminating certain rows, what is going to happen? It is going to, reduce my data. My analysis will be biased in that case, because I am going to delete certain rows, and it may happen that that particular information may be missing for one or two columns, but other columns also may be having some important information, and I may lose that important information because of removing that missing columns. Okay, so important thing is this only, that you should eliminate rows with missing data only if it is very necessary. uh, if that's not the case, just avoid that. Okay, apart from that, you can estimate missing values and fill them with mean, median, or mode. Now this also has a choice, because if you have if you have that data which is good enough for calculating mean, median, or mode, that is okay. You can calculate mean or median of that, or you can say most occurring, most frequently used value, mode, that is. You can use those things. But in case you have a lot of missing data in that column also, and you feel that this particular column may not be able to give you a good mean or something, then you can use default values also. In projects we use default values, where we say, okay, we can set a minimum value as a default value or the standard value that we can use for this particular data, depending on its other features. Okay. Next is your inconsistent values. Your values, your data may contain inconsistent values also. The user may insert phone number in address field. This is an inconsistent thing. Okay, that means some errors may are happening. Okay, human error and something. So data assessment, either manual or through automatic scripts, is very important to understand that whether the data is correct that you are going to analyze or not. So that is a manual task that needs to be done, or it is sometimes done through automatic scripts also. Okay, so that is an important issue. Then you have duplicate values. So for that purpose the data set needs unique values many of the time. So duplicates are removed just to give that uniqueness, the primary factor to your data. For this you can set primary feature, you can say primary column, primary key in your data set. So that will help to maintain the consistency of your data set. The basic problems of your data set will be removed if you maintain a proper primary key and the unique keys also. Okay. Anyways, next task is feature sampling. Sampling is a common method for selecting subset of data that we are analyzing. Guys, just understand this thing that your sample size should be good enough for the machine, because you may be having hell lot of data on cloud. You may be having a good GBs of data that you need to work with. Now you cannot work with entire data as a whole. You don't think that if you have suppose say 100 terabytes of data, you can directly on in one go your server will be able to manage and work on that data and analyze it. That is a very very poor strategy to do. What is a good strategy? Out of your big terabytes of data, you just extract a sample data, try to work your algorithm on that sample data, and if your results are relevant, then you can dig into the more data, you can bring more data and then work on that. Okay, so that is going to be your working process. Okay, so your principle of working with sampling is that the sampling should be done in such a manner that sample generated should have approximately same properties as the original data, meaning it should be a good representative of your original data set. So sample extraction is itself a very very important task when you are working with a huge repository of data. So that data set must be having all the features, all the good representation of the original data set should be there. The properties should be more or less same. Okay, this involves choosing the correct sample size and sampling your data set. Okay. Now sampling strategies. Now how it is done? Okay, what sampling strategies are followed? So one is simple random sampling. You can simply or randomly sample it. This technique states that there is an equal probability of selecting any particular entity. So you can select any particular value for your sample. So it has two variations in it: sampling without replacement and sampling with replacement. You can replace your sample. Once it is taken, it can be replaced with another value and taken once again, or it can not be replaced. Once it is taken, it is taken. Now it can never be taken again. Okay, it has to be replaced with a unique value only. So it has without replacement and with replacement. Okay, so as with each item without replacement, I'm reading, as each item is selected, it is removed from the set of all objects that forms the total data set. Okay, once it is selected, it is removed from that place. It cannot be selected again. And if we say sampling with replacement, then once it is selected, it is not removed from the list. It is there in the list. It has the probability that it can be chosen again in the sample. Okay, so it has a chance of being chosen again. Next is your stratified sampling. So although simple random sampling provides two great sampling techniques, it can fail to output a representative sample when the dataset includes object types which vary drastically in ratio. And this can cause problems when the sample needs to have proper representation of all objects. For example, when we have an imbalanced dataset. An imbalanced dataset, what is an imbalanced dataset? It is the one in which the number of instances of classes are significantly higher than another classes, thus leading to an imbalance or creating rarer classes. Okay, so stratified sampling, it helps you to work with imbalanced data set, because categories may be there, and it may happen that one particular sample may be having higher category as compared to the other sample. So in such case, another technique which is known as stratified sampling is used, which begins with predefined group of objects. So you manually simplify with the help of grouping of objects. You create group of objects, then create a sample, and finally work on with the feature sampling process. Next task is your feature aggregation. Feature aggregations are performed to take the aggregated values in order to put data in a better perspective. Okay, so suppose we have day-to-day transactions of a product from recording the daily sales of the product in various store locations over the year. So aggregating the transactions to single store-wide monthly or yearly transactions help reducing hundreds of potential thousands of transactions. Let me give you a simple example for this, like for example, bank transactions. Take an example of bank transactions. If you have thousands of transactions taking place in a complete day. Okay, now if you just aggregate things, if you just take two roll up kind of thing, like you see it year wise or you see it monthly wise for a particular customer, if we want to see monthly transactions or year wise transactions, then this is a higher aggregation level as compared to seeing day by day transactions, which is at a lower aggregation level. So that level of aggregation, level of detail, LOD, is very, very important, because the more rolled up transactions you see number of transactions year wise, it will give you a better perspective of over a higher period of time, and it will lead to low memory consumption also, and processing time will also be low. Rather than if you go day by day, if you see day by day transactions, then it is going to take hell lot of processing power, hell lot of you can say memory consumption will also be there, because storing day by day transactions is very, very crucial task as compared to just keeping a net transaction of year wise. Like total transaction in a complete year done is 50,000, rather than storing day by day transactions. One day 1,000 rupees, second day 20 rupees, third day 5,000 rupees, and so on. So day by day transactions are going to be more memory consumption related. Okay, so aggregations provide us with a higher view of data, okay, based in groups which are divided into groups, or aggregates are more stable also as compared to individual data objects. Okay, next is your feature encoding, where the whole purpose of data preprocessing is to encode the data so that machine can now understand it. Specifically for that data which is qualitative in nature, we need to quantify that data. But it should be noted that the original meaning of data should not be compromised. Like if I have the data in a column where you are saying about the you can say the country. Okay, the country names are there: India, Germany, and US. Then if you are encoding this particular column, then it will be encoded through a number. There would be some encoded number that will be given to each and every country category. Okay, but the original meaning should be retained. That means we should be able to reach back to that particular value of that country name through that number. So original meaning should always be retained, right? The next thing is feature scaling. As I told you, the small value should not be disregarded by the system, because system is a dumb machine, mathematically based machine, computer system is. So it may give more importance to a higher value as compared to a lower value. Okay, so it may happen that sometimes lower value in a particular column is of high relevance as compared to a big value. So that is something very, very important. So you can see, for example, if an algorithm not using feature scaling method, then it may consider the value of 4,000 meters to be greater than 6 kilometer, because it is not understanding that kilometer word. Now it is understanding that number word. So you can say it may consider 6 kilometers. 6 is a small value. So it is a small value as compared to 4,000 meters. So that is something that feature scaling is used for. So it gives you wrong prediction if you do not use feature scaling. So if you use feature scaling, it will bring 4,000 meters and 6 kilometers into a single platform by scaling them, okay, by scaling them in a range. So that will help the machine learning model to give you better predictions. So we won't have to apply feature scaling for all machine learning algorithms at all times. So this is something very important. This is an optional thing. It may be used if needed, okay, but if you do not need it unnecessarily, do not scale each and every feature, okay. It is only relevant in some specific use cases. So feature scaling method, if you see, there are two feature scaling methods. One is standardization, another one is normalization. So when you talk about standardization, it has a working with mean and standard deviation. So it works with the mean value. It has this formula, you can see, mean value and standard deviation value. When you talk about normalization, then terms in the range of it talks in the terms of you can say minimum and maximum value. So it talks in terms of ranges, okay, minimum value this much and maximum this much, and then it gives you a normalized value. So you can use any of them depending upon what type of data is available to you and what is necessary for you. So you can use any of them. So you can see when standardization is used, how to select standardization. So in standardization, which is also known as z-score normalization, which in you may have bell-shaped curves for these normalized values. So they are basically working and ranging all the data in the range from 0 to 1. This is something important for everybody to understand, that z-score normalization or standardization, when you do, they ensure the mean and standard deviation, mean exactly to be 0 and standard deviation to be 1. That means they are scaling in the range of 0 to 1. The range stands from 0 to 1. So this is used for for algorithms like gradient descent or regression, or those things, neural networks and regression, which actually use descent techniques, gradient descent technique, okay. So I'm not going into that details, that is beyond the scope of today's discussion, but sometime other we'll talk more about gradient descent, we'll talk more about how to standardize these values, okay. So rescaling is also used for these algorithms that use distance measurement, KNN and all those things. So standardization basically deals in the range of, the basic understanding is 0 and 1. So it actually scales in the range of 0 point something, and the more you move towards 1, okay, the more you are moving towards the deviation part, right? So this is the main thing. Okay, normalization. Normalization, again, normalization is known as min-max scaling, and again in this also the values are shifted and rescaled so that they again range in the value of 0 and 1. So that means what ultimate conclusion we can draw is, whether we use the methodology of standardization or normalization, you are going to get the scale in the range of 0 to 1 only, okay. This actually helps, or makes the process independent for the machine learning algorithm, because machine learning algorithm will give the output based on whatever scaling you have done on your features. So whatever scaling process you do, the machine learning algorithm is going to predict the similar type of results only. So this is the conclusion that we draw. So in this formula, we have minimum and maximum values. So when the value of x is the minimum value, the numerator will be 0 and hence normalized value will be 0. And when it is going to be the maximum value, so for maximum value, the normalized value is 1. For minimum value, the normalized value is going to be 0. So the range of values is going to be again in terms of 0 and 1. Okay. Now, specific question, which to use when. Okay, now this is something very typical to know. In contrast to standardization, we obtain smaller standard deviations through min-max normalization. So applying min-max normalization generates smaller standard deviations than using standardization. So it implies that data is more concentrated around mean if we scale data using min-max normalization. Thus, if we have outliers in a feature, then normalizing data will scale data to smaller interval. Standardization does not have a bounding range. So even if you have outliers in all your data, they will not be affected by standardization. So what conclusion we can draw is that standardization is more robust to outliers and is preferable over min max normalization, because in standardization your deviations are smaller as compared to that. So this is very very important to understand that when you have a lot of outlier data, you can say beyond the normal trend data, the outlier data is which is beyond the trend. Okay, some detect fraud data, or we use outlier data when we are detecting frauds and so on. So when you have fraud detection and all those cases, then those outlier data sets, for them you can specifically use the process of standardization as compared to normalization or min max normalization. Okay, because min max, it may happen that the maximum value is itself an outlier, and when you are using min max normalization, then it may lead to wrong direction of results. Okay, if you use min max normalization in this case, right? So this is very important to use. Now, last point, data set splitting. When we use data set splitting, so splitting of data is occurring into two phases. It is training data set and test data set. So training data set, this is that part of the data in which your machine learning algorithm is actually trained to build a model, because you are building your machine learning model with the help of this training data. You can actually train your complete machine with this data. Whatever training you are giving to your machine is with the help of this training data, and whatever the data you are checking the performance of your machine, that you have modeled a particular solution, now you are giving a new data to check its performance, whether it is giving good results or it is predicting correct results or not. So that kind of data is known as test data. So that this is the basic split of your real world data set. Okay, so this is all about the concept of data pre-processing and its task. It is what I have told you is simply a glance upon that. You have a lot and lot of working things, lot and lot of concepts which are present in this flow of tasks that I have shown you. Okay, so guys, I hope you have understood some part of it, what happens in the data pre-processing part, what things you use. Okay, I hope you have gone through all these things, right? So just let me take a break of 1 minute. Let me have some water.
Thank you, Nidhi ma'am. Yes, Nidhi
Yes,
ma'am.
Nidhi ma'am. Yes, ma'am.
I hope
I
the
hope the
hands-on will
hands-on
take
will take
more time.
more time. Yes, actually, the hands-on is a long task. It itself needs a complete session to be
Okay,
worked
okay,
on.
okay.
I hope you arrange some future sessions for a hands-on for this.
Yes, surely we'll arrange a future session for hands on this. We'll be having one more session with you. I hope
Yes, yes.
session 9 we'll be having with you.
Yes,
One
yes,
more
definitely.
session is with you. So we'll be probably expecting a more, not more, very same session, very informative session like today with you again.
Thank you so much.
Everyone expecting with it. So
Yes.
any doubts, everyone? Please, anyone having any doubt, you can raise up your hand. Any queries from anyone, kindly raise up your hand. I hope the session was very informative. You cannot write in your chat box, but we can have reactions from you all. Can I have a few reactions from you all? Yes. Thank you so much. Still any doubts, anyone? We'll just share the email IDs of the resource persons with you. The recordings are being shared with you. All the recordings are being shared with you. The PPTs that we'll be having, we'll be sharing with you in the groups. All the PPTs. Any other material, any other queries you have, you can just put it out on our WhatsApp group also, on our email ID fdp@bciit.ac.in also. Nidhi ma'am, thank you so much.
Thank you so much, ma'am. Thank you,
We
everybody, for
will.
being so patient
We are
listeners.
very delighted to have such an informative session from you. And
Thank you.
yes,
My pleasure.
you would promise us to have another more sessions with us like this.
Definitely, 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 ma'am. On 9th, I have that session with you, and
Yes.
I'll definitely bring, a surprise factor for you all, because I'll be having a real-time data with me, and
Oh,
we'll do some, the visualization and on Seaborn and Matplotlib. I'll show you some fascinating visualizations on real-time data set. So
oh,
that will be, not at all a theoretical one, because these concepts were more of how to do them, how to perform. Before I could start with hands on, all these things need to be clarified first of all. So
okay.
a big task was there for today.
But it was very informative.
Thank
Three
you so
cheers
much.
for you. Thank you so much.
Thank you, ma'am. Thank you. My pleasure.
Thank you. Thank you.
Thank you,
Thank you,
guys.
everyone. Thank you for attending the second day session. We'll have a feedback from you at the last day. And yes, a small quiz would also be shared on the last day itself into the WhatsApp group. Please don't forget to attempt the quiz and another factor with your attendance. Okay, these two have to be qualified for getting the e-certificate. Thank you so much for being a part of the FDP organized by BCIIT. Thank you, everyone.
Thank you, ma'am. Thank you.
Thank you so much, ma'am.